Experiment 3. Electrochemical cells. Objective for this experiment. First, to construct electrochemical cells. Second, to arrange aluminium, zinc, magnesium, iron, and copper in an electrochemical series. And third, to determine the Faraday's constant by electrolysis of copper to sulfate solution. Introduction. Electrochemistry is a study of the relationship between electricity and chemistry. Generally, there are two types of electrochemical cells, namely galvanic and electrolytic cells. A standard reduction potential is defined as a reduction potential obtained at a standard condition where the concentration of solution is 1.0 molar, the gas partial pressure is 1 atm, and temperature is 25 degrees. The potential difference between the two half cells in an electrochemical cell is called cell potential. The cell potential or the cell voltage at the standard condition can be written as E naught cell equal to E naught cathode minus E naught anode. The cell potential at non-standard condition can be calculated by using the Nernst equation. E cell equal to E naught cell minus 0.0592 divided by N log Q.
A useful galvanic cell can be constructed by using zinc and copper. The anode is a zinc bar placed into a zinc sulfate solution. And the cathode is a copper bar placed into a copper 2 sulfate solution. The two solutions are connected by a porous sodium chloride salt bridge that prevents the two solutions from mixing but allows ions to migrate. Attaching the cell shows that electrons flow from zinc to copper. Because zinc is a more active metal than copper, it is more likely to lose electrons. For this reason, the zinc bar is oxidized, producing a zinc ion and 2 electrons per zinc atom. The copper ions in solution gain 2 electrons and are reduced to copper metal. As the reaction continues, excess positive zinc ions build up in the zinc solution. At the same time, the loss of copper ions from the copper sulfate solution creates an excess of negative sulfate ions. Positive sodium ions migrate into the copper sulfate solution from the salt bridge, while negative chloride ions migrate from the salt bridge to the zinc solution and maintain neutrality of the solutions. The reaction stops when the zinc bar or copper ions are depleted.
Experiment 3, Part A, Galvanic cell. Step 1. Clean the metal strap with sandpaper. Step 2. Fill a 50 ml beaker with 35 ml 0.1 molar copper 2 sulfate and the other beaker with 35 ml 0.1 molar zinc sulfate. Step 3. Set up the apparatus as shown. Step 4. Record the cell potential. Step 5. Repeat step 1 until 4 by replacing zinc aqueous / zinc solid half cell with A. Magnesium strap in 0.1 molar magnesium sulfate. B. Aluminium strap in 0.1 molar aluminium nitrate. And C. Iron strap in 0.1 molar iron 2 sulfate. Part B. Determination of Faraday's constant. Step 1. Clean a copper electrode with a piece of sandpaper. Step 2. Weigh the copper electrode accurately. Step 3. Fill a 50 ml beaker with 35 ml 0.1 molar copper 2 sulfate. Set up the apparatus as shown. Step 4. Complete the circuit at step 3. Set the transformer to supply the direct current with a voltage of 3 volt. Step 5. Run the electrolysis for 15 minutes. Step 6. Record the ammeter reading and your observation of each electrode. Step 7. Disconnect the circuit. Step 8. Dry the copper strap using a hair dryer. Step 9. Weight again the copper strap. Thank you for watching. Please like, share and subscribe our Crack Slab channel. Have a nice day.